Chegou a hora da nossa entrevista. Estou aqui com o Antônio Vilela, que vai nos ajudar a bater um papo aqui com o Matt.
Tudo bem, Felipe? Um grande prazer. Vamos lá.
Vamos de novo aqui nessa dinâmica que foi um sucesso aí no último evento. A entrevista vai ser com o Matt Piper. Ele é diretor global de soluções da Esri para os segmentos de utilities, telecom, saneamento, AEC e infraestrutura. Vamos tratar aqui das mudanças recentes no segmento de energia elétrica, destacando algumas tendências do uso das geotecnologias que podem ser valiosas para o nosso público aqui no Brasil. Bom, como já apresentei, estou aqui com o Antônio Vilela, conto com ele aqui no estúdio mais uma vez para essa dinâmica. Ele é Country Manager da Esri para o Brasil. Seja então, mais uma vez, muito bem-vindo aí, Vilela. Obrigado pela sua presença e apoio nessa dinâmica aí que vamos realizar.
Eu que agradeço, meu cara, estar aqui mais uma vez com vocês.
Legal. Vilela, sabemos que você possui uma vasta experiência no atendimento de clientes no segmento de energia elétrica aqui no Brasil. Antes da gente começar as perguntas para o Matt Piper, gostaria de saber qual sua visão sobre o movimento que essa indústria está vivenciando agora aqui no nosso país.
Perfeito, Felipe. Obrigado aí pela introdução. É um prazer enorme estar aqui com vocês novamente. Eu vou tentar ser bem breve, porque eu acho que o importante é termos aí a experiência aí do Matt para dividir com a gente, mas rapidamente, assim, Felipe, a indústria de utilities em geral e obviamente as elétricas está num momento muito particular e transformação, não só no Brasil, mas eu acho que no mundo todo. Então, as concessionárias de energia elétrica enfrentam mudanças em praticamente todas as áreas de negócio. Elas trabalham duro ali para se adaptar e aproveitar a tecnologia que tem nas mais diversas áreas. No entanto, elas frequentemente enfrentam desafios de hoje, mas com as ferramentas ou os métodos de ontem. Então, isso precisa e está realmente mudando. Na luta para essas empresas permanecerem relevantes e prosperarem, as concessionárias elas realmente devem buscar o que tem de novo e tem muita tecnologia disponível no mercado. Por exemplo, a gente vê uma tendência grande mundial, não só aqui no Brasil, mas ao redor de todo o globo, as implementações de ADMS. O ADMS, o GIS, tem um papel protagonista, porque vai alimentar todo esse sistema da AMS com dados ricos para que realmente o ADMS ele faça sentido. Então, as empresas elas procuram o ArcGIS para obter as últimas novidades de mapeamento de utilities, análise espacial, no fundo, para construir o que a gente chama de Digital Twin, ou o gêmeo digital de toda uma operação da empresa de energia elétrica. Então, rapidamente, e já antes de passar a palavra para o Matt, diria que os principais tópicos hoje endereçados por um GIS moderno são, obviamente, a modernização das redes, gestão de crise, operação de campo fundamental, e tudo isso não faz sentido se realmente não tiver um BI para fazer esse analytics e essa análise de todos esses dados. Então, eu não vou alongar mais, vamos então começar a entrevista com o Matt. Felipe, por favor, faz aí as honras da casa.
Obrigado, Vilela, pela introdução. Bom, vamos agora começar a nossa entrevista. Matt, seja muito bem-vindo. Sabemos que estamos vivenciando uma grande mudança no segmento de energia elétrica, no mundo e aqui no Brasil. Com a sua experiência no assunto, gostaríamos de saber quais são as principais tendências e impactos desse novo cenário.
Hi, Felipe, and thank you for inviting me to speak at this Utility Summit. That's a great first question, and I think to answer that, we should start by recognizing that the utility industry is going through a lot of change. And this is occurring both at the amount of change, but also the speed of change. And from my experience, having worked in the utility industry for almost 25 years, these are two things that utilities do not like to do a lot of. Utilities are quite programmatic with their change adoption. They do not like to be running large consecutive IT or transformation projects in parallel. And they typically like to not be on the leading edge of any new technology adoption. But right now, we're at this point in time where utilities are having to think very differently if they are going to evolve and meet the demands of what this new future in energy is transforming to. Now, if I was to think about these three things in sort of three buckets, about the drivers for this acceleration of change. The first would be the known challenges. So the known challenges are things that are fairly traditional for utilities, things like aging infrastructure, could be aging workforce, the adoption of smart grid and IoT deployments, or even something as foundational as just trying to improve your data quality. The second, I think, are the unknown challenges. These are the things that utilities must react or adopt to. The good example of this is, dealing with emergency response and preparedness. So natural disaster events like wildfires, hurricanes, and extreme weather events are happening both at now a higher frequency and a higher severity than ever before. But there are also things like changing policies or regulations, or commitments to things like the energy transition goals, or even the impacts due to things like COVID-19 pandemic. The unknown or the forced work in a utility used to equate for about 10% of the total work from my experience. But what we're seeing now is that this unplanned work is actually equating to the equivalent of 20 or 25% of the annual work for a utility. And finally, the third trend I'm seeing is the rapid advancements in technologies that utility requirements are driving. To improve efficiencies, manage the modern grid, optimize their operations, the utilities are now looking for new solutions to help solve some of their previous challenges. But they're also looking to the future and trying to understand, how do we set ourselves up for success? And this really just further highlights if there's any legacy constraints that may exist in the organization. These things might exist because of customized or in-house solutions or legacy integrations that are now acting like this anchor, which is preventing the organization moving forward despite all their best intentions. Now, as you know, Felipe, while the rate of change in utilities is really fast now, in fact, we've seen more change in the past 10 years than we have in the previous 100. It's worth noting that it's never going to be this slow again, which is quite scary when you think about it. But what this means is that it requires an understanding of some of the modern technology capabilities. It requires a revised vision and strategy from both the business and the IT leaderships. But most importantly, perhaps what's required is that we need to rethink our existing operating models and business processes if we're going to achieve this vision of what a modern utility is going to be in the future.
Perfeito, Matt. Muito obrigado pela resposta. A minha próxima pergunta, ela vem no sentido de que o GIS não é novidade para este segmento. Então, as utilities, na verdade, as empresas de energia elétrica são heavy users do sistema ArcGIS já há muitos anos. Então, é das indústrias mais maduras utilizando o ArcGIS. Mas, neste momento, como é que você vê o sistema ArcGIS se adequando para suportar as demandas de agora o que é uma rede moderna?
Thanks, Antonio. That's a really good point, and you are correct. GIS has been used by utilities in some form or another for a very long time. Utilities in general have always had design teams, and from the very beginning, the importance of mapping the linear network was understood and was carefully redrawn onto paper. So from the very origins, utilities understood the need to think spatial and lay out the network to help with planning and rectification or inspection work. And as technology has evolved, these paper maps were digitized and utilities began to establish entire GIS departments. Now these teams were essential as they kept all the information current for the normal or the as-designed state of the network. But as I mentioned earlier, we're going through significant change, and it's widely recognized that the grid that we have today is not going to meet the demands of the 21st century and beyond. But Antonio, I think this question can best be answered through a few graphics. So let me just start up a few slides here and I'll step you through some animations. Okay, here we go. Let's start with the more traditional electric grid. Now, most people would be familiar with the grid shown. We start with a power plant and it runs through a transmission network through the substations, converting a high voltage to a low voltage, goes through the distribution network and eventually ends up at the customer. Now, the gas network is much the same. It runs from the pump station, the wellhead, through to the city gate, where there are some storage options, but eventually we have a regulated gas network going back to our customer. And of course, in both of these examples, the common node is the customer. Now, if we transition and look at what the future grid looks like, or a modern grid, we begin seeing the renewables are actually coming onto the grid in the forms of solar and wind farms. We see an increase in grid battery storage systems and distributed energy resources, which is generating back onto our grid. But it is the customer where most of the change is occurring. The customers have moved from this consumer model to a prosumer. And the introduction of large-scale green energy choices like rooftop solar, battery storage systems, and even the purchasing of electric vehicles, these are all having significant impacts on the grid. And as these renewables are beginning to scale up, we see further developments and the emergence of things like microgrids and other renewable options. Now, if we look at this from the gas network, we see the same sort of thing happening. At the generation component, we're seeing things like biomethane and biogas coming onto the grid, generating renewable energies into the grid. This is then running along the regulated network and once again goes back to the customer. The customer now has more choice. The customer is now more informed, and they are requiring to be kept better engaged. They are effectively making decisions about how our grid is operated and how these things are influencing our grid. But managing a modern grid is not just about renewable energies. It's about so much more. What we really want is an intelligent grid. We want to know what is happening. We want to know how it's happening, what time of the day it's happening, and how are all these things we discussed influencing the grid so that you can make better decisions. And many utilities have already made significant investments in rolling out things like smart meters and IoT sensors. But now we're faced with this challenge. What do we do with all this data? We're trying to understand that now you have all this information and it's coming back in. How can I make smarter decisions? And so many of these decisions are dependent upon location. So let's look at some common use cases of how location and GIS are essential to improving business processes and decision making through this digital energy and utility enterprise. For generation, GIS is used for site suitability analysis and running forecasts on future renewable resource requirements. It can also assist with understanding how your organization is tracking to achieve their renewable targets or better plan and align for a lot of these future capital expenditures. At the transmission level, GIS is used to assess network vulnerability, helping utilities prepare, respond, and improve your overall network resiliency. A common example is vegetation management. GIS is used to run the inspection programs and also provide analytics for vegetation encroachment to assist in things like fire mitigation. It is also used to capture, monitor, and locate asset failures and to improve the response times at your organization. For the distribution network, GIS is critical. It's critical to almost every workflow. But beyond managing the network design and the connectivity, it is also used to optimize customer connections. It's used to visualize the integration and impacts of distributed energy resources on the network. But more importantly, it also unifies all the field workflows. At the customer level, GIS is used to improve the way utilities communicate and engage with their customers. Customers really do now expect timely communication and access to things like self-service portals to make informed decisions for themselves. And finally, we see GIS becoming integrated into the control room to improve overall decision making. The GIS connects large disparate data sets and geo-enables the decision making for real-time network management. It provides better understanding of risk and gives real-world context for coordinating field operations for restoration work or planned inspections. Now, as you can see, GIS is used across the entire utility, and it's core to managing a modern grid. Now, if you look at this new modern grid and the direction that the industry is going, I'm sure that you can agree that the grid that was built in the past will not meet the requirements of the future. But the same can be said for your enterprise applications that support this network as well. When a lot of this technology was developed 10 or 20 years ago, it was not foreseen how much change would impact the industry. So it makes sense that many organizations are assessing their core enterprise systems to make sure they are set up for success.
Excelente, Matt. Bom, relacionado a mudanças climáticas, desastres naturais, eles também são grandes desafios para as utilities. Conta pra gente, Matt, como o GIS está sendo utilizado para enfrentar esses desafios.
Sure, Felipe, no problems. Now, as I mentioned earlier, utilities are going through a lot of challenges and a lot of change. But just when you think you've had enough to deal with all these different challenges, along comes the next round of natural disasters or these major unplanned events. And I know this region is very familiar with dealing with their fair share of natural disasters. But what I didn't know until recently was that the Latin America and Caribbean region ranks number 2 in the world for natural disasters. And in the past decade alone, there have been about 150 million people impacted from about 1,200 significant events. And what's more amazing is that this is a combination of almost every type of major event, whether it's floods, storms, drought, fires, landslides, or even earthquakes. But as I mentioned earlier, it's not just the frequency that these are occurring. It is also the severity. So to answer the question on what is GIS being used for during these type of events, I thought it might be a good idea just to share a personal story on this matter that I hope answers this question, if that's okay, Felipe. So the story I'd like to share is related to a tropical cyclone that impacted the Australian coastline in 2017, just before I moved over to America. And as it turns out, that this was a very memorable cyclone and one that had many firsts for me. Now, Australia is very similar to Brazil in that it is always being impacted by natural disasters. And this is evident in this map I'm showing here. So I created this map to show the amount of cyclones in the area that occurred just in the past 10 years. And that they overlaid that with the association to the electric network. So myself and our organization were also fairly familiar, as you can see, with dealing with natural disasters. And we had many standard operating procedures in place to deal with such events. So not only was this the last event I got to manage before moving to America, it was also one of the most challenging. And let me tell you why. So a tropical cyclone had formed off the coast, and it was still a fair distance out, and it was only a Category 1 at the time. So our utility had well-defined procedures, as I said, for managing these type of events, and we began to mobilize our incident response team. So my team had begun the planning for the possible event, and we used GIS to determine where the possible path of the cyclone was likely to cross and what potential impact this would have on the assets in its path. In addition, we also ran some preliminary storm surge models and flood impact analysis to gauge both the customer impacts but also the potential network impacts. We also mapped out the evacuation areas, we modeled the staging areas, and we also identified all the critical or life support customers in the region. So as it was a relatively low intensity cyclone, we were really only in the prepare phase and not fully mobilized at this point in time. But all that was about to change very quickly. So in the space of about 48 hours, the cyclone changed direction, has accelerated towards the coastline, and intensified from a Category 1 to a severe Category 4. So needless to say, this caught many of us by surprise, and we immediately had to go into full response phase. So the cyclone did cross the coast. It was a severe Category 4, and the damage that was incurred by this cyclone was extensive, and there were significant and widespread outages over a very large area. But it was during these times that you really do start to appreciate how important a GIS is. This is when it can really shine. So for the first few days, due to the fact that all the roads were damaged, so we couldn't get many crews out, we couldn't get any planes in because no flights were able to land, we only had access to a few local crews in the region that were actually able to go out and do damage assessment. But we had to get insights onto what was happening. So in the space of a few hours, we spun up the Esri ArcGIS Survey 123 application. And this was used to create electronic forms so that we could go out and do rapid damage assessment. So we dispatched the crews and they were out now capturing the defects in real time, providing us back the insights so we can start managing our operational decisions. So as you can see here by all the orange dots on the map, these are all the defects that were captured by the event. It was also possible to keep track of where the crews were in real time, understanding where the vehicles were as they moved around. So the green cars in this map are the ones that are moving and the red ones were the ones that were stationary. And this was a great tool to assist in both coordinating the response, but also the rectifications and for safety purposes. So in addition to this, we were actually able to get small manned aircrafts into the air to fly over all the area that was more remote or that was too isolated that we couldn't get crews there. So the imagery that was captured was brought back and analytics were performed on it, and it was used to identify that we had poles down or conductors down. So all the imagery and the defects were also brought back onto these centralized dashboards, and we used web maps as a way of managing this. From here, the GIS was used to create restoration zones and work was assigned. So now we're moving into the restoration. So crews were dispatched based on predetermined priorities, but this is when things started to get really interesting for this event. So just as we were starting to ramp up from the damage assessment to now the restoration, the cyclone had already crossed the coastline and it moved slowly inland and a little bit south, but then it just stayed there as a very large tropical storm or tropical depression for about a week. This delivered unprecedented amounts of rain, massive downpours which filled up all the catchments in the region, resulting in all the rivers reaching record heights and breaking their banks. So all of a sudden, we were now dealing with two simultaneous events that were in different regions at the same time. So as one event has moved into restoration, the other event now was in preliminary planning and doing the analysis once again of where are the network at risk, what are our priorities, how do we move into establishing all the staging areas and evacuation zones from the flooding. So this shows the different scenarios that can be running and how GIS is used to do this. So in this particular example, we started to model all the flooded impact zones and where we needed to mobilize crews immediately. Now, as you can see from this list of the apps and maps and dashboards which were created, these were all created in real time during the event. They didn't exist before the event, but using GIS, we were actually able to spin this up and respond in record time. So GIS is critical for managing these type of events. And in addition to the ones I discussed, there are also these other tools that we use, such as social media maps, which brings together data from Facebook and Twitter, as well as many public-facing outage maps or storage maps, which we use to keep our customers informed. And as I said, Felipe, this was really an unbelievable event. But despite the severity and all the obstacles that were in front of us, the utility was able to restore all the power within about 2 weeks, which, if I recall, was a record. And you can definitely be certain that a lot of this success was attributed to the GIS and how it was able to put information in the hands of all those who need it to make better decisions, to prepare, respond, and recover faster.
Obrigado, Matt. Caminhando agora para o final, e de forma muito pragmática, onde você enxerga as maiores oportunidades para aplicar o GIS nos próximos anos?
Oh, Antonio, that's a good question. Where do I see the biggest value? Well, for sure, I am really excited to see what our customers are going to do now that they are moving to the utility network and how this new foundational technology is going to unlock so much more of their enterprise capability. But where do I see the biggest opportunities? Well, once again, I think a picture is going to say 1,000 words. So I'm going to bring up some slides here to talk through some graphics because I think that's going to help tell the story better. So something that makes GIS unique is that it is architected in a way that it creates business value through a geospatial infrastructure. A geospatial infrastructure interconnects and integrates, creating relationships and streamlining many, many different workflows. So everything has a location. So location becomes this common key to integrate these siloed solutions, and it allows for the modeling of this complete life cycle. And to best answer your question, Antonio, I think I'm going to step through each one of these key workflows. So let's get started with data quality and management. So from my experience, data quality has always been a challenge for utilities. It's difficult to capture, even harder to keep current and maintained. So data quality and management really is foundational to a utility. It's all about being able to model the data, capture it, integrate it, and then manage it and its associated attributes and behaviors throughout its entire life cycle. And in recent years, there's been significant investments in GIS, which are architected in a way to better enable this data capture, integration, and management. With the release of the utility network, there's many reasons why this technology is going to be so transformational. But one of my personal favorites is that it's now 3D enabled. And as a result, it unlocks many additional capabilities of the requirements of what a modern GIS is looking for. So it allows you to model the facilities like substations in 3D and see how they are connected to the rest of the network, all in spatial context, both above and of course below the ground. And finally, if you look at the bottom the right-hand side of your screen, you see how GIS is integrating information models and systems together. In this particular example, a facility was scanned with LiDAR. This scan was then converted to a BIM model, which allowed detailed visualizations and attributes to be associated. And then in addition, this information was then integrated back into the asset and works management systems to bring up all the additional information of the work orders. Now, this is showing the fully integrated workflow from data capture to the model and then integration back into enterprise systems. Now, GIS is also significantly advancing in its capabilities to better manage the design and engineering workflows. So just look at this example here on the screen and see how GIS is evolving for utilities. Now, there are hundreds of assets in a substation, but for the longest time, these were just represented as a single dot on a map. But with the release of the utility network in conjunction with ArcGIS Pro, the substation can now be modeled in spatially accurate context or as a single line operating diagram. And in addition, it can be visualized with base maps or in inferred 3D. And now with the advancements with our integration with our partners in the design space, we can now bring true 3D models like things from AutoCAD or Revit files, and these can be ingested and visualized in context to the network. So not only do these 3D designs look fantastic, but they also streamline many workflows and create new opportunities for managing the as-built and mobile workflows. Now, by using GIS to bring together different data and information models, it also allows for this notion of coordinated operations. So what does this mean? Well, in summary, information is created once and then shared as required to everyone who needs it in a secure way. This means that the network that the control room sees is the same network and information that the customer service sees, that the asset manager sees, and it's the same information that they see in the field. This information is not recreated, it's not duplicated, but it's pervasively shared from a single source of truth. So this data can be edited or captured, and it is then seamlessly updated back into the source systems. So what is also really important to understand is that ArcGIS manages access through identity and roles. So organizations can control who can see what data. They can control what they can do with this data, whether they can edit, create, or view. And then they can decide what functions they are able to perform when using that data. So things like, can they do tracing? And all of this is done while adhering to your business rules and your security configurations. The need to be able to model and visualize how assets, structures, and networks are operating in real time continues to increase. Now in 2020, there are now more than 50 billion IoT devices globally, and organizations are needing to bring these critical data sets together to support their real-time awareness and decision-making. So one of the biggest areas of concern for many utilities is the as-built processing and providing mobile workers with up-to-date information. Now, it's common to have significant information latency as jobs are backlogged waiting to be updated into the corporate systems. So GIS is now essential to the delivery of these projects and these work information packages. It provides the advanced visualizations of all these complex and big data sets to aid in streamlining these many workflows. So at the top of the screen, you can see a representation of a bridge construction, which is tracking the delivery of this project in 5D. So this is 3D with the addition of time and cost. And at the bottom of the screen, you can see another really great example of BIM and GIS integrating in 3D. However, this time it's configured in an operations dashboard, which is also connected to real-time operations data. Now, this is now bringing together a holistic view for managing this site. Another area of significant development in recent years is the way GIS is analyzing and providing insights for future outcomes. So GeoAI and the advancements in machine and deep learning are really transforming digital workflows and really automating many of the processes. So utilities are using these tools for object classifications, like determining whether or not there's solar panels on the roof, or doing suitability analysis for site selections. But they are also using these image classifications for things like 3D damage analysis, which are required to be done after a natural disaster. Or they're using the AI and the machine learning to train models to manage the vegetation encroachments and optimize other maintenance programs. And finally, GIS is being used to assist in predictive modeling. So looking forward to the what-if scenarios, it provides the capabilities to run all the predictive analytics on future failures based upon the historical records, and it will even improve some of the work plans for tasks like route optimizations. So some very, very day-to-day operations as well. So an area that GIS plays an essential role is in how it supports the sharing and the collaboration. So it's customers first, and the customer needs are changing. And GIS provides the timely communication to people and to the communities. GIS is essential to providing the necessary capabilities to take the information captured and analyzed and share it to those who need it in a dynamic and visual way through applications like story maps, operation dashboards, or even web apps. This data, once again, it is secure and it can be shared in a collaboration both internally and externally, which really does improve that information transparency and the citizen engagement between the utility and some other constituents.
Excelente, Matt. Bom, uma última pergunta para finalizar. Você, com a sua experiência como diretor das utilities, diretor global na Esri, quais fatores-chave para o sucesso das utilities nesse novo momento que estamos vivendo que você linkaria para a nossa audiência aqui no Brasil?
Wow, Felipe, what am I seeing at a global level? Good question. Well, really, from my time working with utilities around the world, I've got to see some amazing examples of how GIS is being used. And I've definitely come to appreciate that not every utility is at the same maturity of their GIS deployments, or even more broadly speaking, at the same point in their digital transformation projects. But one thing that has become very clear is that there is this huge momentum to help educate the leadership across organizations of the value that a modern GIS brings. And for many organizations, this can be a really big challenge. And largely this is because GIS has been ingrained in the utility for so long. And there is this perception of what a GIS does and also what it doesn't do. But for those that are really starting to be successful, and they're the ones that are re-educating the IT departments and the leadership teams, we're starting to see that the GIS is delivering capabilities across their entire organization. They're going well beyond the traditional design and engineering or the mapping departments. They're going deeper into asset and operations management. They're helping the customer care team understand their customers better. They're helping to adhere to safety and compliance while still delivering some of the most world-class analytics and business intelligence. And that's not just internally in their organization, but they're also doing it externally, as we talked about, for those citizen engagements and that reporting capabilities. And one of the biggest shifts in thinking for many of the organizations that we're dealing with is that the advancements in technology required for their modern digital grid or these large transformational projects, it really comes down to how critical this relationship is between their ERP, their GIS, and their ADMS. You see, a modern GIS is not just that design and mapping application anymore. The GIS works to provide this additional value, and it brings together these ERP data sets, things like the assets or the inventory or the customer information, and it brings all this ERP information together through location, and that helps you better assess asset failures and better understand risk profiles. It also optimizes a lot of your maintenance programs and streamlines your mobility workflows, so you can roll out better inspection programs. And it definitely helps you adhere to some of the best practice asset management standards like ISO 55000. But the GIS also acts as this bridge between your enterprise systems, and it provides what has come to be known as this OT and IT convergence. So the GIS can pass network and asset data from the ADMS, as well as provide the control center and the operations room with additional information with things like weather, traffic, some of the environmental layers. And this information can assist when dispatching crews or prioritizing any of the work. So the GIS can take the ADMS data and it brings it back into the GIS, and then it can share it across the organization. So what does this mean? Well, this means that the current operating state of the network can now be shared throughout the organization. So you now are not just delivering as traditionally the as designed state or the normal state. You're now taking the as operated state of the network and permeating that through your organization. So this really does significantly improve information latency. And if you're a field worker out in the field, it also significantly improves the safety. So GIS provides this pivotal role, bringing your ERP systems together with your ADMS and your SCADA data and all these other systems. And it extends the capability of all these other strategic investments that you've made within your organization, but it creates this additional value while also reducing a lot of these point-to-point integration costs and overall reducing that technical debt of these disparate or legacy systems in your organization. But a modern GIS, a modern comprehensive GIS, goes beyond just that transactional data. So the modern GIS is designed to work with these enterprise systems, and it delivers solutions across your whole organization. And we always discuss this as it being done in three ways. So it is this system of record. It connects your GIS and all these other systems, as we just spoke about, to manage the transactions and all the associated information governance. Then there's this system of insights. Now the system of insights brings all this data to life. It helps you make these better business decisions by utilizing things like advanced spatial analytics and all these other technologies like 3D or AI and machine learning. So this enables you to better understand any patterns or trends, and it enables you to visualize data in dashboards and creates all these out-of-the-box reporting capabilities. And finally, we have what we call this system of engagement. So this is the notion which provides the ability for the enterprise collaboration. So out of the box now, users can control what they share and what the users can see and what the users can do, as we spoke about earlier. And I think we must be about at time, Felipe, but I'd just like to add one final comment before we finish up. So for all of this stuff to work, everything I spoke about today, it really does require organizations to think differently. And often the pathway to success is achieved by creating this notion of thinking spatial first. And this all happens around establishing what we call this modern geospatial infrastructure. So with that, thank you very much, Felipe.
Excelente, Matt. Excelente resposta. Agradeço mais uma vez a oportunidade, é uma honra aí receber esses insights diretamente de você, não é não, Antônio?
Espetacular. Matt, eu só tenho a te agradecer, realmente foi um privilégio muito grande para mim e acho que para todos nós podermos ter, enfim, estado com você na última hora. É uma aula sempre poder contar com a sua experiência. Então, pessoal, a gente acha que se vê mais tarde para falar um pouquinho agora mas de águas com o diretor global aí de águas da Esri, o Dave. Então, continuem aí, tem bastante conteúdo aí ao longo do dia de hoje. Espero que aproveitem.
Isso aí, gente. Continua essa discussão com o nosso time. Existe o chat aqui na página do evento. Você pode entrar em contato com especialistas e vamos seguir que tem bastante conteúdo. Obrigado a todos.